Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new.
Hey, welcome everybody. Welcome to Skytour live stream. It's Mark D'Antonio here, your celestial navigator. Kind of like sleepy time tea. Anyway, Daryl's with me. Hey, Daryl, how's it going?
Hello, Mark. I'm well. You? Hello, everybody.
Just fine. Yeah, I'm running through
Bluebird Day in Colorado.
Oh yeah, that's beautiful. It was kind of cloudy here earlier, but it's actually cleared up very nicely. Okay, our spider web's back, as you can see in the observatory. So we have our wind meter. Just kidding, but it's pretty cool.
Spiders always seem to cast their nets a lot this time of year.
Oh yeah, that's right.
When I still had a big lilac bush in front of my house, every year about this time of year, a big old orb weaver spider would spin its web between the bush and the roof line on the front of my house.
Yeah, this is now when they do it. It's their time.
Yeah.
Yeah, their time. Yep. Okay, so I'm just doing a focus run here. This is not perfect, it's close, but I will do another one. We're just waiting for it to get completely dark out there. So this is Nunki, the star, as Daryl was mentioning earlier, offline. It's the star, the upper star in the handle of the teapot of Sagittarius. You can actually see the handle right here, and then this is the teapot right here. And the top of the teapot is Caus Borealis. And then you have right here, this is the tip of the teapot right here, this star here, which is Al-Nasl. So we're actually over here at Nunki, or Nunki.
Well, when you see Caus Borealis there, if you continue down, you see Caus Media, and then Caus Australis at the bottom corner of the teapot. Those make the archer's bow.
Yeah, let's actually back out and see if Stellarium did that.
And Al-Nasl is the tip of the arrow.
And they didn't.
Of course not.
Yeah, it's like they ignored the mythological approach to this, which is kind of typical, isn't it?
Artistic license, I guess.
Yeah, I guess. Or artistic destruction of the license.
I wonder at the ancient Greeks' frame of mind that they'd look up there and see a half man, half horse shooting a bow and arrow. I mean, that's quite a picture.
Yeah, why didn't they see a teapot? I mean, teapots have been around since that time.
We see a teapot. It's like Homer Simpson. When he looks up in the sky, he sees cowboys.
And donuts. Donuts. Hey, Homer, look, a peanut. Yeah, so I want to say hi to Michael Glee, who was first. Nice to see you, Michael. And we have Tiffany's with us. Sam S. has joined us. And JSCO is here. Nice to see you, man. Kathy Prunasek, hello. That's X-Lady, of course, and I knew that. And then we have Paul Babadia. How you doing, man? Or no, that's Raul. Sorry, Raul. I apologize. Raul Babadia. I'm looking at the screen, and there's so much small text. I didn't get to really see it too well. Apologize for that. Yeah, so we're going to start moving up already. We've done a lot in the Milky Way there. We're going to check out this guy right here. This is a non-globular cluster, but it looks like a globular cluster. It's called the Wild Duck, and you'll see it appear in here. And we're in our low light mode, so you'll see a fuzzy thing just start to, there it is. Fuzzy thing shows up, and I'm going to move it all the way over to here and take a picture. I'll tell you why. Because it's right on the edge of what's called the Scutum star cloud, and I want you to see the star cloud. It's pretty cool. Yeah, there we go. All right, and while I'm here, I'm going to take the time to do another focus run here, because we'll get it perfect. What happens is when the telescope looks up, the mirror moves a fraction of a millimeter, and when that happens, that actually causes a slight defocusing, and we have to correct for that. So I'm now doing this. Right now we see 8 stars. You can see down here in the lower right. And now that number will increase. Okay, so right here. You'll see now it's 30 stars, 14. And so now what I'm going to do is I'm going to start focusing. And you'll see that it's going to start increasing the number of stars it sees. The yellow squares are the samples. Now we're up to 38 stars, 20 stars, 30 stars. The numbers will just keep going up. 105 already.
Does it choose stars of a certain brightness or dimness to calibrate against?
I think it tries to collect a mix of bright and not so bright stars, because the bright stars can fool it, and the real faint stars are actually the best and more accurate ones. So it might actually be skewed toward the fainter stars. You'll notice this star up here has not been selected.
Yeah.
Okay, you'll notice this star has not been selected. But you notice that a lot of the stars you can't see have been selected. Okay, including some in the cluster. So it's using fainter stars that haven't had that don't have a saturated core, and that kind of makes sense because you get the best image that way, right? As you can imagine. So that's kind of cool.
That's kind of what I figured.
Yeah. Did I just see that Mr. Django says he just woke up? It's 4:30 a.m. Man,
Yep.
wow, that's pretty cool, Mr. Django. That's Stephen Smith. Hey, Stephen, it's nice to see you. Thanks for coming. Cindy Murphy's with us. Yes, sirree. And I just want to ask Raul Babadia, what is your interest and your most passionate thing in astronomy that you enjoy? Let's see if we can't find something that you in particular might actually find very interesting. You know, I haven't seen you here before, so I figured why not ask. Okay, we're all focused with 152 stars. Use the samples, and we'll get rid of this now.
Raoul was here the other night.
Yeah, no, he was, but I didn't ask him this question. I figured I want to find out actually what his passion in astronomy is, so he can, if he shares that with us, then maybe we can show him some cool things that are what he's looking for. Okay, so I'm going to move this now over, and to do that, we're going to actually slide to the west with the telescope. You won't see it really happening up there in the telescope because it's moving kind of slow. We're moving very, very small amounts.
No, you get to move it east.
What?
I said, now you get to move it east.
What do you mean?
Are you moving away from the cluster?
On purpose, because I want to bring the Scutum star cloud in. That's what I said earlier. I'm putting it over here so that I can capture it and the star cloud right here, because there's some nice dark nebula in here that's coursing around. I'd like to check it out and see how it looks.
Sure.
I'm going to go down to 250 gain. And, you know, for those, you know, again, just to point things out, there's a photograph right there that is just a quickie. The most important elements here, this is our telescope control. This is our telescope computer view. This is the telescope. This is some dummy that doesn't stop talking. This is the most important field on the screen, the exposure, and second most important screen field is the gain. Sensitivity of the sensor is the gain, and we set that sensitivity, and then we expose that sensitivity value of the sensor to a certain amount of seconds. And so playing these two against each other can give us the best result possible. Naturally, this is the view window. Down below, you'll see a stacking window here in just a moment. And the other thing you'll see is this. This is our planetarium view. This is connected to our telescope. And right now, we are down in the Scutum star cloud. Okay, this thing right here that's bracketed, that's this thing right here, Measure 11, the wild duck cluster, and this is the Scutum star cloud, and this red square is our field of view. So if I bring this up and zoom in, okay, you can see this is the STLS area, and if I do that and center it, okay, this will give you an idea of where we are. We're actually right, let me just do this. We are right here. This is where we are. Okay, so this is what we're going to take a picture of, and we're going to do it for 25 seconds. All right, so we are guiding. You can tell because up here we have numbers. These are the movements in fractions of a pixel to try and correct the screen. It's taking an image, you can see by this yellow down here. So off we go. And now we're going to throw in that live stacking screen. This is the image. We're going to take a first image, and we're going to take a second image, stick it on top of the first, align it with them all stars to stars, and then keep doing it over and over and make an image sandwich. And all the data we get is going to produce an image that is noise free. Okay, so this is our first image. I'm going to take this off because we don't need it. It's actually over processing, so we're going to reduce that down to something more viewable. We're going to color correct by doing this, right? And then we're going to process do a basic processing of this scene. Now, you'll notice that right now that you see stars, but you see some dark patchy areas. Well, these dark patchy areas are areas of dark dust in our galaxy, created by supernovae and large supergiant stars that slough off their outer layers and make molecules of this dust way far out, away from where the action is taking place in the star. And thus they create this dust, which is scattered throughout the galaxies and universe. So it's actually a very interesting thing. I'm gonna just bring the music down just a tad here. All right, so it's not fully dark yet. We're getting a little infection, but we can still see some red diffuse clouds. There's some red nebula in here, and these are the star clouds. Okay, and there is this object in the star cloud. We've actually captured 3 images. You can see right here, 3 images captured, and 1 has been rejected. Sometimes, if there's a little wind out there, we'll get an image that shakes a little bit, and it changes the diameter of our stars, makes them a little bit elongated. When that happens, we want to make sure that we don't use that in our image, because all the stars will be elongated. So to get perfect stars, we do this. So I'm going to actually drop this down a little bit more, bring it to 7.27 and 6.91. 7.27 will still be a good show here for this. All right, so now that you have all that information, I'm going to start looking at some of the processing here.
Raul answered your question.
Okay, Raul likes the Sombrero Galaxy. Yeah, okay, that's a really cool galaxy. We've seen that. Yeah. Oh yeah, sky full of stars in the Dominican. Yeah, the Dominican Republic. Beautiful. Enjoy learning anything that was to do with stars and galaxies. Okay, Raul, you know what we're going to do for you? Tonight, I'm going to try to get us an image of the Andromeda Galaxy for you. It's up now. The thing is, we have to make sure that it's up high enough, because if you look up at the building there, the Andromeda Galaxy is going to be out in this direction, out what looks like the back of the observatory. That's actually toward the northeast, and the Andromeda Galaxy is going to be toward the northeast. So we want to make sure it's actually going to be over there a little more. We want to make sure that it's going to be above our roof line, which will be soon. If not, while we look at other things, you'll see it. So Raul, tonight we're gonna do this for you and get you a galaxy image. Those aren't the only ones that are visible, but it is the most impressive one that's visible.
And you'll actually get 3 for the price of 1.
That's correct. Yeah, you're right. Yeah. Daryl's referring, Raul and everybody, to the fact that the Andromeda Galaxy has 2 satellite galaxies around it. It has M32, and M31 is the Andromeda Galaxy Messier 31, M31. And Messier 32 is one of the companion galaxies, which is basically a ball of stars. It's called an elliptical galaxy. And then you have Messier 110, which is another one. And that's above the Messier 32 and Messier 31, and it's more of an elongated elliptical galaxy. And we rate elliptical galaxies with an E for elliptical, and they go from like I think 0 to E7, something like that, I believe. And so the Messier 110's something like an E5-6, maybe 7, and Messier 32 is more like a E2 or E1. It's not as elongated. And Fongwei's with us. Hey, Fongwei, how are you? Yeah. Fongwei says, wow, I'm glad you chose Andromeda. I used to stare at it for hours and hours with my 16-inch Dob. It's simply amazing. Yeah, you can, with a 16-inch Dobsonian telescope, okay, you can see a lot of details with your eye that elude many other telescopes with your eye. And the 16-inch Dob is really cool. So I'm sure the views are beautiful. Could you see the, and I'll ask you this, and maybe you know this, maybe you don't, but you'll let me know. Can you see any of the OB associations in the Andromeda Galaxy's spiral arms? Those are the bright blue stars that are in the spiral arms. That's where they're formed. And they're type O and type B stars, so they call OB associations. I wonder if you can see those.
I have a 16-inch Dobsonian. If I had been married, I would have gotten divorced over that telescope. Thing is huge. It's a pig.
Yeah, but I'm sure you could see beautiful Andromeda galaxies.
Yeah, you betcha.
Yeah.
You cross the threshold at about the 12 or 13-inch aperture line, where the telescopes increase in size, opens up a whole new world. It's like a different experience than looking through a smaller telescope.
Yeah. Exactly. Okay, so this is Measure 11. We've done 10 images. I will mark this as Measure 11, and this is the name that I'm putting in up here. And so when I hit save right here, you'll see there's a green bar that comes across, and it says blah 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 blah, the name .fits. Now that's an astronomical file format, and unless you know how to work with that, that won't be much use to you. But we do save exactly as seen, and that saves a PNG file. So when you go to our server, for free, you can download this image. Okay? So we make this available to you for nothing, because we believe in the passion of spreading astronomical knowledge. And so this is something you can get for nothing. If you want to support us, you can buy stuff from our Etsy shop, which you can see right here. Okay, SkyTour shop. You can go to skytourlive.org right here and join our Patreon and support us that way. And if you go to skytourlive.org, if you don't want to join the Patreon for a monthly amount, you can make a one-time donation. Just click the donate button and support us that way. But no one says you have to do that. We definitely could use it. Obviously, none of us are actually getting paid. When I got my degree in astronomy, my whole goal was to take it to public outreach and basically teach people about the universe, and that's what I'm doing. And Daryl was kind enough to say, hey, I can do that too, and so he's joined on with us, and he's part of us. He's a very valuable asset in astronomy to us in this endeavor. And so together we take people on tours of the night sky, and occasionally we'll disagree on a few things, but not much. And Daryl might disagree with me on that. No, I'm just kidding. So we've got 14. We're going to go to 15 here.
Ow. Sorry, I was biting my tongue.
That's funny. Okay, we got 15, so we'll save it. And then we'll save it exactly as seen. Okay. All right, so now we've taken that picture. You saw me saving it, so the question is, where's it going? It's going up to our server at skytourlive.org right here. Okay, and at skytourlive.org, if you scroll down, you'll see a section that says, hey, take me to cool pictures. And you can read the instructions there. And this image I just took is probably already there. So if you go there and scroll down and say, take me to cool pictures, sift into the directories, you can get that picture I just showed you and download it. And that's literally, we're running about 30 seconds. So every time we take a picture, about 30 seconds later, it shows up on the server. That's pretty good, isn't it? And these pictures are pictures that you can, use, take down, use for your whatever you like. If you want any of the more fully processed ones where all of the remaining noise has been removed and the colors have been perfected, well, that's for our Patreon subscribers, and you can get those images too. those are the kinds of images that people blow up and put on their walls. Those are the kinds of images that people put into prints and so forth. We already have that. If you go to again skytourlive.org, you can go say, let me buy cool prints. And instead of going to Skytour shop where you can buy things on coffee mugs and mouse pads and sneakers, okay, any of our prints, you can get the imagery under glass, on canvas, on metal, so many different options. So you have the ability to get our photos in a true fine art way, if you like. And any of you who have visited our Sky Tour, I guess, showroom, that we don't rent space. It's in the house of one of our organization folks, Marianne. She has a lot of the pictures up on the wall of different kinds, and they're stunning. It's like it's like being in an art gallery. They're just so beautiful. But you're seeing the universe live in all of its colors, here. And hey, Water Rat's with us. That's Matt. Matt used to work with me here. He may be coming back. Matt, I got a big potential model project that may require some assistance if you've got some time. All right.
What happened to the image?
Oh, I stopped taking the image. I ended it, and I just haven't gotten to do this part yet. I mean, the more time I take, the longer the Andromeda galaxy will get higher. Because I want to head up into the north. And there goes. That's the live. See, a satellite zipping through. Okay. Now it's long like a line because we're taking a 1 second exposure. See, here's that number I told you. We're doing 1,000 millisecond exposure. So each frame you're seeing here that's popping in, it's popping in every second. And so every second you see the satellite image that came through as a dash, because that's the line of the satellite going through the image. Okay. Let's do the following. We are going to go to our stellarium view, and we're going to run up the Milky Way here through Aquila the Eagle, which is here. And there's Altair and Tau Z. And we're going to come up here. This is Sagitta or Sagitta. Depends on how you pronounce it. And we're going to check in on this guy. This is the most beautiful planetary nebula in the sky next to the Helix. And so we're going to head up to this and check it out. All right. And this... Go ahead.
Sagitta is arrow.
Yes.
What it means. But oddly enough, it's not from Sagittarius.
Mm. Right. And let's now move the telescope to the west a little bit and bring this in. I'm 2,600 miles away from that telescope up there. I'm in Connecticut, and I'm running it from here. So it's really kind of funny when they go out to do maintenance out there. I'm in Connecticut, and they'll say, "Okay, open the roof." And so I open the roof, and right in front of them, the roof opens up, and it's like it's something that just, I don't know, just never gets old. Just never gets old. Kyle says he was confused by Measure 11. Yeah. And Steven says, Mr. Django says, yes, beautiful coffee mug. He got one. Yeah, that's right. I remember that. And thank you, Daryl, for putting up the OneDrive link.
Yeah.
Let's zoom in here and check. We've gone way up. Let's see if we have to alter the focus. I think we're going to have to refocus again. And that's okay. Because by refocusing, it's going to give us the best possible result. That's what I like doing. All right. So tonight it's 10:48 here in Connecticut, and I'm going to end by midnight because I have a radio interview to do tomorrow. I'm doing a conference here in Connecticut in the next couple of weeks, and I have to go on a little media blitz and start to I have to start talking to folks and pushing what I'm talking about. I'm going to be talking about interdimensional travel with the potential for extraterrestrial life to use that technique. It's something that Avi Loeb at Harvard actually has been talking about lately, and I've said before how I know Avi. We've worked together on a couple television projects, and he's a very, very smart guy, and he wouldn't make those kind of commentaries if he didn't have evidence for it. And I've been saying for about 4 or 5 years now that I believe that's how they travel. It's actually the only way I see how they could. And I guess I'm not the only one that feels that way anymore. And that's good. Science needs to embrace this a lot more actively. Mark Young, what's happening? Nice to see you.
I still want my flying car.
I know, right? Mark Young's saying he's imaging the Dumbbell Nebula right now with the Sea Star. That's fantastic. I'm just doing a focus run here, Mark, and I'm waiting to see if it's gonna put a focal point right around here. It should. If it doesn't, then I'll have to do it over again. Yeah, it didn't do it. Okay. That's good. So that's fine. I will just do it again. I'll bring it back. I didn't give it enough of a curve on the left side. I need to be out of focus by just a little bit more. So maybe out here. And yeah, that should work. So I'm going to reset and do it again. Now we'll go negative again, and we should now get a good focus. I didn't give it enough. I didn't give it a deep enough curve on the right-hand side. Let's see. The Dumbbell Nebula is fascinating. It's called a planetary nebula because in a telescope you could be mistaken for thinking it's a dim planet, because if you squint at it, it could kind of look like a planet. The Dumbbell is a nebula which was created by a star sloughing off its outer layers as it aged and grew into a red giant. And then when they get into red giant stage, they reach several stages of red giantdom, and that's when they run out of their hydrogen fuel, which is powering them in the beginning. And then they start to pulsate, and they go through these things called thermal pulses. And these thermal pulses will thermally pulse and push stuff off. Then it'll shrink, and then thermally pulse and push stuff off. And that is the process by which these nebulae form, these puffs, these thermal pulses. And so when we see a thermal pulse like that, and we see a nebula like this, then we know that the nebula was going to have these concentric shells, perhaps, or maybe the nature of the star and the way the star was rotating might change the nature of what we see. This is an example nebula of that type. This nebula is not a spherical. This is not a spherical nebula as you might expect around the star. This actually, it looks like an apple core, but it's not really an apple core. It's actually a what's called a bipolar nebula. It's got a mount to the top and a mount to the bottom, and then there's some on the outside here. As we now go in and take an exposure, you'll see we're going to do a 20-second exposure. It doesn't need much more. This is a very bright nebula. So we'll take this exposure and we'll get out of our low light mode and go into deep sky mode. And that's deep sky mode is coming up. And you'll see the last one we did. This is that object, Measure 11 with the Scutum star cloud. So we'll clear that. And now as the first one comes in, you'll see the Dumbbell Nebula. And there it is.
Imagine if that was an apple core, we'd all be in trouble.
I know, right?
What would be out there big enough to eat an apple core that size?
It's on its way here. It's coming right for us. Okay, I have it kind of over processed right now to the point where you actually see that it's got these shells. You can see these shells of ionized gas out here. But if we actually do process it to show what's going on, all right, I'll bring this. This is the dark level. This white bar, this white curve is the average of the red, green, and blue curves. The image is made up of red frame, green frame, blue frame. Okay, and so if I move the black thing to just to the left of the peak like this, then the image is just about as dark as we want it to get without losing data. And then this is the mid-level over here. And because 20 seconds is long for this nebula, I'm going to drag this way down here to show you the interior of the nebula. And when I do that, you can see when we zoom in, you can see that we've got this red material here, this red material here, and we have something like this. This is a star in the very center. It's actually the remainder of a star. This is a white dwarf. It's about the size of the planet Earth. And this particular nebula is, oh gosh, I think we said, what, 1,500, 2,000 light years away?
I think so.
And we can still see this tiny point source light, the size of the Earth, just over 1,000 years away in time and distance for light travel. And light moves the fastest that we know in the universe. So it's over 1,000 light years away, 1,500 light years away, and we still see something that size because it's so powerful. The light is so intense coming from it that it shows up from this distance. And it's also giving off a great amount of ultraviolet light. And so much of its light is in the spectrum, the part of the spectrum we can't even see. And so it's actually ionizing the oxygen that's here. It's ionizing the hydrogen that's in this area. Stars are made of hydrogen, and the oxygen you see is oxygen that the star was made with. It didn't necessarily make it, okay? But it's pretty cool. And so when we look at this color here, this is the color of ionized, doubly ionized oxygen, where 2 electrons shoot off the atom for a period of time. When they come back in, they give off light, and that particular light is this bluish green light. Hydrogen only has 1 electron, and when it ionizes, and the electron ionizes, leaves the atom and comes back in, well, it gives off red light primarily, and that's called hydrogen alpha. So we get red light and we get bluish green light from ionization most places in the universe, and this is an example of it. Hey, Wayne Pinkham, how you doing? Nice to see you. C&D Boy, what's going on, man? Rocket City, welcome to the party. So there you go. So there is the dumbbell, and notice these shells on the outside. Look at this big one. This was stuff that was sloughed off way in the beginning. Now if I bring this back, it'll enhance that a bit. Okay, now you can see more. Now that also takes away the ability to see in the core, but you gotta pick and choose. What do you want to see? What we want to see is all of this out here. You can see all of this material.
You're picking at it very well tonight.
Yeah, isn't that nice?
That outer shell.
Yeah, it was. You can see it's got a separation. There's one here, and there's another one here with a separation between them. Really cool. Let's see if we can brighten the core a little more and see if we can pick out that stuff even more. And we can. Yeah, it shows that really, really well.
If you look closely at the nebula, the two red areas at the top and the bottom, there is a brightest section on the top one over on the left side, and on the bottom one it's over on the right side. And if you look carefully, you can see sort of like two rays or beams coming from the white dwarf at the center. That's where those rays are hitting those shells, where the hydrogen is brightened the most. And the whole thing appears, if you look at the whole apple core shape, the top half and the bottom half, it's like two cones put together. It's like those beams or those rays, jets, are precessing over time, spinning around, so to speak, and making those two conical shapes.
Yeah, this star could have been a fairly rapid rotator when it first started to die, and so what will happen is the north-south pole is this way on the star, and this is the equatorial line through here, and so the star will be bulging at the equator, just like the Earth does a little bit. So it's an oblate spheroid, not a round spherical star. And if it's rapidly rotating, you can imagine that a lot of material might be shot off equatorially along that, out from the sides of the star as it's rotating. And that could be what we're seeing here. We also see a lot of material out here, which indicates that material did get ejected from the poles, but not as much as ejected from this location along the equator. So this is like the north-south pole. So really, in terms of exactly what we're seeing, it's kind of like this. This is kind of like the north-south pole right here, and this is the equatorial. Oops, sorry, not that one. And this is the equatorial region right there. So let me do that again. So this is the north-south pole here, right here. Let me do it again. There's the north-south pole, and then we have the equatorial region right through here. All right, and so you can imagine it spinning around that equatorial region, and the white dwarf might be like, spinning like that on its side as we're looking at it. But we still get stuff out there, and we get a preponderance of the stuff here. And if it's precessing, as Daryl was talking about, something we've talked about often, then it's doing this. It's going like this. Okay, very, very slowly over time, and that could have been because of the way the star began to slough off its outer layers later in life. So it's interesting. Donald King is with us. How are you? And he says, you can see what appears to be a bar from upper left to lower right. Precisely correct, Donald. That's this guy right here. That bar you're talking about right here. Sorry, right here.
What I just talked about.
That's right.
Water Rat asks, how do we know it's north and south poles?
There's been studies, Matt, that show what's going on here, and bipolar nebulae have a pretty well, they're non-standard planetary nebulae, but they have a fairly well understood topography and I say emission, and so there's studies that show different conditions that generate certain types of these bipolar nebulae, and this is one of those. This is one of those things that is in there in the study. Timmy Despain, how are you? Nice to see you.
Would it be fair to say then that if you say its spin axis is running from upper right to lower left, the two poles, whichever one is north and south, that the magnetic poles are offset, causing those two jets?
I'm not sure. It's possible. I mean, if the star is precessing for some reason, then that could be alone what's causing it, and it wouldn't require a magnetic field to do that. But this jet is interesting because maybe this is currently, I don't know this for sure, but this could be the current orientation of the white dwarf in this nebula. And maybe it's slowly going to be shifting, and as it moves away from there, the jets end up looking like other areas like this, so they don't actually look as bright anymore. It's possible. I don't know. I'm curious about that particular aspect of it.
Well, that's why I said if you look closely, and it might be more obvious if you just up the red a little bit, the brightest parts of the red on the top one is at the left side, and on the bottom one is at the right side, where the red is most intense, and that appears to be where the two jets are striking at the moment.
Yeah. I added some more red.
That the precession over time could be as, where it's been in the past and where it's going to be moving to again in the future.
Right.
And I would assume that those are showing the magnetic poles ejecting the rays.
Well, if I read this nebula correctly, I think that the north and south pole is along this line. So because this would be evenly split, left and right. So this would just be a precessing star. I know what you're saying. And as the star is precessing, is it possible that what this line represents is the center of the precession cone that the star is going through? Right?
No.
Because that's what it would be.
I mean, if what you're drawing is the north and south poles, and it's spinning, around that pole, that axis, then
Precessing around that, yeah.
Something has to be creating the jets. As we've seen with other astronomical objects, jets usually come out at the poles, either physical poles or, like geomagnetic if it was Earth, or geophysical if it was Earth, and magnetic poles.
Yeah.
The jets often ride the field lines.
I agree. But what I was suggesting, and I didn't quite draw it right. Let me draw it right again here. What I was really suggesting, though, is that if we look here and say that's the center, okay, it's just a little off. This line, I could imagine that this angle is the angle off of the center of the precession, the original pole, okay, and that it's pirouetting around that. So it's doing that around this pole. This pole line here is a phantom pole line. It's not pointing north and south on this lines anymore, but that's the center of the precession line. That's how I view that. See what I mean?
Okay.
And so what you said could also be true, because that works that way too. That's what I'm thinking. I saw a study, and I got a bipolar nebulae study, and it was on Dumbbell, and it showed it specifically, and it talked about some of this. So we'll check it out at another time. We'll bring it up. Let me bring this down a lot more just to show you the interior. Okay, so now you see the interior again. And you can see very clearly now we've got 38 stacked here. There is the white dwarf in there, shining away. And here is these bars that, again, right now the white dwarf is probably oriented with its poles this way, but based on the apple core shape, okay, it looks like it's been precessing wildly with almost like a 35 degree or a 70 degree total arc. So it's rapidly moving around, and maybe this is exactly what we're looking at here, because those jets usually come from the poles, as you said. And so the current location of the poles could be, as you said, along these jets, but the actual axis around which it's pirouetting is going to go straight through, because it would bisect this side and this side directly. I find it interesting that this red area extends out further. Do you see that?
Yes, I do.
Yeah, and I think if we just drop this in for a minute.
Looks like that's the hot spots where the
Yeah,
jets are passing through that layer, whatever it is, the eyeball shape.
yeah. That's the, yeah.
When you see this in the eyepiece, it's gray. You don't see the colors, but you could almost imagine, maybe Mark, if you backed out a little bit, that when you see this in the eyepiece, where they get the name planetary nebula, those two bright areas, the two cone shapes in the eyepiece, are reminiscent of like North and South America in a picture, like if you were looking at a globe like that. Can you kind of see that? That's why they called it planetary nebula. It sort of looks like a planet, a ghostly planet.
Yeah.
Space ghost.
Right. Chase, let's get blip.
Ever watch Space Ghost Coast to Coast?
Oh gosh, that was terrible, but yes,
Oh, I love that show.
I had to watch it.
Yeah, I had them all on tape.
Yeah.
Then I sent them to a friend in Canada. He never gave them back.
That's the last time you sent something to Canada, right?
Yep.
Unless you sent it to C&D Boy. That's Doug, I think. I think he lives in Canada. He's a good guy. He's a respectable Canadian. So, there we go. All right, so we saved it's M27. We're going to save it, and as before, we're going to save the astronomical file format, and then we'll save exactly a scene. Okay. And now, we'll back out, show you the full frame. I'll do this too because I'd like to show you this. So we're going to just do that and drop this for a moment and just zoom in to kind of let you see the whole thing. There is the Dumbbell Nebula. For years I had a poster of this on my wall, and you know what? None of this outer stuff was in that poster, and this was an official observatory photograph taken with like the Hale telescope in Mount Palomar, and none of this outer stuff was there. So I thought that was interesting.
I've seen that in some older astro images. Seeing M82 and Ursa Major back in the old days, those two red blazes coming out of the middle of the galaxy. You never used to see those in
I know.
photographs.
I know.
They show up easily in the digital images.
Now they do, yeah.
Yeah.
Yeah. I want to say hello to Cosmic Flow 888. What's going on? Nice to see you. Yeah. Cosmic Flow always says hi to you. It doesn't say hi to me.
Because I said hi to him.
Oh, you did? Oh, okay.
Yeah. This is one of the first deep sky objects I ever looked at.
I think it was second after Alberio for me. You know, the beautiful visual double that makes up the head of the swan.
Well, deep sky objects,
Yeah,
meaning nebulas
sure.
and clusters
I bring
and
my
galaxies.
telescope back here. Okay, and now what we'll do is bring up and redock our data here. Save it one more time.
Michael, when you look up in the sky, everything you see is spinning. Everything.
Mm-hmm.
Stars, planets, galaxies,
Gas.
you name it. gas, everything is spinning.
Now people look at the moon. We ask them if the moon spins, and they say no, but it does. It spins once per orbit around the Earth, which is why the same face faces us.
It rotates at the same rate it revolves.
Yeah.
Hence shows us the same side more or less all the time.
Mm-hmm. All right, so let's do this now. All right, so we'll get out of this. We've taken a number of these photos. They're up there. And we'll go back to our low light shot and go to something else that I was like to show folks. My midnight deadline is approaching in about 45 minutes. And for those joining us, I'm going to end at midnight tonight because I have an early morning thing I got to do tomorrow. All right.
I get to wrestle with the cable TV guy tomorrow.
Oh, how exciting. Not. Okay, so. Yes, this is. Wrestling with this is another thing altogether. But this will work. So. Let's go look. Alright, there's Draco. That's the M13. That's beautiful. There's the Andromeda galaxy. Let's see what its altitude is.
You're almost as high as Polaris.
Yeah. I'm trying to read that. I can't read it. Why am I not able to read? Oh, I gotta move it. Alright, that's with altitude. Oh, 41. Alright, we might be able to capture the Andromeda galaxy now. So why don't we try that out? This is kind of a... Although he didn't request it directly, Raul, this is for you because you have decided to hang out with us tonight, and I think that's pretty cool. So I am going to be happy to bring you to the Andromeda galaxy. Alright. You'll watch the telescope start moving. Here it goes. We're going to zoom out now.
Django has a question for you.
Okay, 1 second. I'm actually... There it is. And we have a little bit of the building that may or may not be in the way. Well, we'll find out. Okay. Oh, Izabela is... the database is actually done. We're just trying to get the Apple folks and the people... Well, actually, the people that are hosting our application, I'm trying to get them to respond to requests because I want to actually start putting this out there. So it's very frustrating.
What's the holdup?
The holdup is that they needed me to prove that we're a non-profit company, which I did. I sent them all that data, and it's like they're not getting back to me to say, okay, excellent, we're gonna let you publish now. You know, and we have to outlay money to do that. Okay, this is the side of the nebula. The side, it's one half the galaxy. The other half goes out the top, but trust me, it goes all the way down here. So that's why I'm being so careful to place it here, so you can see the rest. It may not look like it goes far. It may look like it ends kind of like here, but it doesn't. It goes longer than this view we have. So we'll do half and half. All right. So this will be a 20-second shot, 25-second, actually. And we're guiding now, so we can start off and go into low light out of low light mode and go into deep sky mode with a preview of the Dumbbell Nebula left behind. That's already up and saved, and we will clear this because that's saved up there. Hey there, Marco. And you'll see that we're about to get our first image of the Andromeda Galaxy. There it is. Okay, now let's do what I want to do. We're going to get rid of the telescope for now. And we're going to dump our stack screen. We can still see everything. And zoom in on this. So you can just see that. Look at that. That's beautiful.
When we talked about 3 galaxies in one, you can see 2 of them right now. You'll see the third one when he does the upper half of the galaxy.
Yeah, because right now we can't see it. This is one of the elliptical galaxies. This is Messier 32. Messier 110 is up outside our view right now, just outside. So this, as I told you, you'll notice, look, it's bigger than this view as well. Let's do this. I'm going to color correct this. Alright. Alright, so we'll color correct it. And let's do some processing, see where it wants to go. Let's make it pretty bright. Alright, so that's there. Now, these blue clusters of stars are the OB associations I was talking about. O stars and B stars. They're very, very bright. All these stars you see, by the way, that's the veil in our galaxy. You're looking at a galaxy way out here. You can't see the individual stars in this galaxy. At most, you can see the individual globular clusters in this galaxy. Those might be some of the tiniest dots you see in this image. Okay, but you can't see individual stars at this distance. All right, this is stunning. Okay, I'm going to also darken up our background a little by bringing this up the curve. There we go.
Professional observatories could pick out individual stars in Andromeda.
Yeah, with the focal length, but we're a wide field scope.
Yes.
I don't think we could see it even if we were at narrow field. With our second scope, we have a second telescope going in. I'll be out in Arizona in a couple of weeks, and I'll be visiting an observatory site where we may be moving both of our telescopes to. This telescope and the new one, which we have currently in our office out in Mesa. And those 2 telescopes will live under the same roof and be able to provide simultaneous views. One is the wide field scope, which is what we have here, and the other is a narrow field. So whereas we see all of this, with that next scope we might just see this. And it's going to allow us to look at planets. It's going to allow us to see craters on the moon. In a very, very deep dive, we'll be able to explore the moon now. It'll be a lot of fun. Cosmic Ray is here. Hey, Cosmic Ray. He says, how does this camera perform with much longer exposures? I have done 3-minute and 4-minute exposures. And what I find is that the noise level actually gets less when I do the longer exposures, because as it's building up, it's constantly changing the noise, and so it starts averaging out. If you do short exposures, you see lots of noise. You do longer exposures, the noise sort of starts to go away. It's a weird phenomenon. But the way the noise works in the camera, it's random. You know.
Wouldn't you turn down the gain for longer exposures?
If you want to do something faint, you leave the gain up and then do longer exposure to, have like a 4-minute shot at 250 gain as opposed to a 4-minute shot at 150. The optimum gain for this camera is 100. And that optimum gain I almost never use because I want to show this incredible detail. And we are we're kind of crazy. We like to, and we will remove a lot of the noise in our images.
You talk about observatories. I saw something rather sad today.
What's that?
On YouTube, I've been watching a guy who's in the process of hiking from Delaware to San Francisco, and he's been crossing Colorado lately. He's just about to hit the Utah line, actually.
Wow.
And his last couple of vids, he has been up in what's called Grand Mesa, which is a huge flat-top mesa over in western Colorado.
Yeah.
East of Grand Junction. And I mean, the mesa is huge. It's I've been on it before, and it's high altitude also.
Yeah.
Well, he's been in the process of crossing it, and he's getting close to the end of it today. And he passed an observatory as he was hiking along. And this observatory, excuse me, I'm going to cough. Sorry.
It's all right.
This poor old observatory, it looked like somebody had big plans. There were two domes there, and there was a large paved area that had what looked like a bunch of piers on it. And the whole thing looked derelict.
Wow.
It was just sad to see.
Well, maybe it was a light pollution issue in the end. Or
well,
a mortality issue.
That's more likely, I think. It's not a lot of light pollution over there. Of course, Grand Junction is to the west, and that'll be making some, but look like somebody's hopes and dreams, you know?
Yeah, yeah. I want to say hi to Olivia Hodges. Hi, Olivia. How are you? You know, if you guys haven't, some of you haven't subscribed, please subscribe. It's all free. This image, download for free. You go to, skytourlive.org, and you could download this image. Right now, we're full screening this so you can see it. I want to zoom in now that we've got 16 stacked images here. And I'm going to show you a few things. Namely, this is a beautiful star cloud, okay, of blue, hot, young stars. This is dark spiral arm dust you see here. And this guy right here is a nebula. So in reality, when we look at another galaxy, we'll see things like this. We'll see things like this. Okay, like this, right? And then these dark lanes. So we're looking at many different types of features in other galaxies that we also see in our own. It's a very interesting thing to view. And so when you look at this is a star or two or three or more, and they're illuminating and dust in here, but they're also ionizing hydrogen, and that hydrogen gas is glowing, which is why you have this subtle red color here.
That's like Orion Nebula in Andromeda.
Yeah, it's like an Orion Nebula in the Andromeda galaxy.
It's a star factory.
Yeah, a stellar nursery, yeah. Very, very cool. And all these stars, as I mentioned, that you're seeing here, those are in the foreground in our galaxy. And the Andromeda galaxy, is way far behind it. Only the smallest objects you see here might be large, either clusters of stars, like globular clusters, or we might be looking at some other associations of stars. Like, for instance, right here you can see like this faint area. I'm going to zoom in on that. Okay. Here, when you look here, right, it looks like we can see like some stars in here, but they're actually not. They're not stars. You're looking at more than one. So there's like clusters of stars in here that we're seeing. Remember, this is 2.4 million light years away. So we're not looking at stars at that distance with this particular telescope. It's a wide field system.
I saw another astro imager's picture of Andromeda earlier tonight, and that area right there really stands out. It's, not counting the nucleus, it's one of the brightest areas in the whole galaxy.
Yeah, I actually can probably even punch that up somewhat too. Bring it up like this. And now you can see that it's actually quite bright.
Oh.
You know. But you're right. And you can see how blue it is. The spiral arms of a galaxy are normally where new stars form. You see some other blue areas out here. It's very stunning. I'm going to redock our stack right now. And I will bring back our telescope. Okay, go. Thank you. All right. So now we can see the detail in this beautiful galaxy. This is the nucleus. This is the realm of older stars. That's why they tend to look yellowish. They're older, more evolved in general. The youngest stars are in the spiral arms. That's where all the new stuff is being made. There's very little new stars being made in the core.
Don't they say now or think that there may be 2 supermassive black holes at the nucleus of Andromeda?
Yeah, I've heard that before. I haven't read the studies myself. Hey, and Izabela's here. Hi, Izabela.
Izabela's here.
Yeah. Donald King, how you doing? Nice to see you. Yeah. Hi, Daryl. Hi, Mark. Hi, Andromeda. That's funny, Izabela. Yeah, let's darken up our background just a little more, as much as we dare, and then it'll normalize. And there it goes. And now we have, you can see the detail here. Let's actually add what's called the unsharp mask. Watch these dark lanes over here. Watch them change and get a little bit more sharp. Ready? Here we go. Boom, look at that. Now you can actually see more detail in here, more convolutions. So the noise, it comes up a little bit, but the benefit is we get to see this incredible detail in here. Very nice. Very cool. Okay, this is 27 images, 28. We'll save it here. I will change the name. We'll call it Measure 31. That's the galaxy. And let's save it. There it is. And then we'll save it exactly as seen.
Mark, did you lose your sound?
No, I'm still here. Do you not hear me? Can you hear me?
I heard you just now.
Okay.
You went away.
All right.
Can you hear me now?
Oh yeah, I hear you fine.
All right. Yeah, you dropped out.
Okay.
Can the people hear you?
Yeah, no, I was broadcasting. I think they all heard me. You might have been the only one that didn't for some reason. Yeah.
Not my fault.
Oh no, not your fault. No.
I didn't do it. Nobody saw me do it. You can't prove it.
That's right.
Nobody saw me do it. Can't prove a thing. Out of the way, Homer.
Yeah, okay. So what we'll do now is, since we saved this and got it out there, we're going to actually hop out of this, and we're going to do the upper part of the galaxy now. And we're going to be in our 1 second low light shot, and that will be our kind of like our finder. There we go. And I'm going to move up and over, so I'm going to bring this up. Galaxies are only ever faint fuzzies in the eyepiece unless you really have a big telescope or the ability to take a long exposure. Here is measure 110 out here. Okay, so we'll be able to see that now. I'm only going to move over a slight bit more to bring in more of the galaxy up into the diagonal corner. And measure 110 I'll keep in the field. Alright, I'm going to go down a little more here.
Izabela, I think Triangulum is a little farther east. It may still be behind the roof line.
Yeah, we can see. Alright.
It'll be up soon.
Yeah.
If not already. Maybe we could try after Andromeda.
Okay, there's measure 110. Alright, and here is the galaxy, and we got it going up to the diagonal. That's the best that I can get it right now. And what we're going to do is do a 25-second shot. Same as before. And we'll start that. Jump out of low light mode. Go into our miraculous deep sky mode. And you'll see the lower part of the Andromeda galaxy right there. It goes down here. And what we'll do is we'll be able to combine this for you to make one image. Alright. And that's kind of cool. So, I'll clear it. And the next shot you see coming in will be of the upper part of the Andromeda galaxy. So that should be right now. If it didn't come in, it means that we had a... Yeah, okay. Just off nominal. I'll just pop that up a little bit. 7.6 will work as well. That's the highest threshold of non-roundness that I'll tolerate. Hey, Victor Anthony, how are you? There we go. Victor Anthony says, I always think you look like the Mandalorian. It's just the lighting, man. See that beautiful blue arc up there? That's going to be even more visible. Notice that second shot came in. We suddenly got a lot better image. That's what happens. So Michael Hedrick, how are you? There's the nucleus. We had that in the last shot. And look at all this blue. There's a knot of stars up in here. There's some nebula over here that'll be coming out pretty soon. Excellent, Michael. Great. I'm glad you're great. Very nice.
I've said before, you're looking at what made Edmund Hubble famous.
That's right.
Hubble was an eminent astronomer about 100 years ago. He discovered the true nature of galaxies outside our own Milky Way. He, who was it? Henrietta Swan Leavitt, I think, a lady astronomer. She discovered so-called Cepheid variable stars, Cepheids. They're variable stars of a particular kind. Their brightness and the period of their pulsation are related. Anyway, Miss Leavitt discovered Cepheid variables, and Hubble learned about them, and Hubble found Cepheid variable stars in the Andromeda galaxy.
Yeah.
And because he could detect the period of the star's variability, he knew how bright the star should be. And he compared its theoretical brightness to how bright he measured that star in Andromeda, those stars in Andromeda, and just did some math and figured out how far away they must be to be that dim at whatever distance. And that revealed the scale of the universe to us. And that's why the Hubble telescope is named after Edwin Hubble.
And that's why Edwin Hubble was absolutely perplexed when he first came up with that finding, because it didn't seem right. But there was a suspicion that these were distant objects anyway. So that's pretty cool.
But they didn't know it until he proved it.
That's right.
A lot of people thought they were so-called spiral nebulae inside our own galaxy.
Yep, that's right. In fact, I have a book here called Architecture of the Heavens and a Series of Letters to a Lady, published in the 1800s, first edition. And I've read from it on the radio show in the past, and I've also read from it on this broadcast. But that book, aside from being flower letter language, is because in the past, astronomy was not considered a real science. And so the only way that astronomers in the 1800s could get their points across and their explorations out there was to write about them in a series of letters to a lady. So, as if he was writing to a loved one, a female in his life, this particular astronomer, Nichols, writes a series of quote-unquote letters, and they're written very flowery language style. And there's actual plates covered with little tissue paper on each page where there's a plate. And they're not photos, they're drawings. They were engravings that were then put into the book. So it's really quite a valuable little book if you're a collector. So it's an interesting story. I've read the book. It's very hard to wade through, by the way, because to read the book, you have to be able to read. Again, it's tiny print, but you have to be able to read words you haven't seen before and that are spelled differently than you know. It's really interesting. Yeah, Daryl says it's romantic to some of us. Izabela says that it's when astronomy was still romantic. Well, I am fondly in love with the universe, of course, and I think people know that. Daryl is too. Izabela is too. So, we actually Izabela doesn't come on with us much, but she's in most of the streams. Does an incredible amount of work. She's built the app that we're trying to get out there, and she does our table of contents. She also offers amazing stuff. She'll put up the links for a lot of what we're doing. And, I've never met her. She's all the way over in Bulgaria, So I think that's pretty cool. Yes, we are, I guess we're dinosaurs in a way because of the romance of the universe. I haven't let the technology that I use get in the way of the awe that I feel when I see something for the first time. I haven't let that get in the way. Yes, it's fun to find exoplanets, okay? Yes, it's fun to be a discoverer. Yes, it's fun to be part of a grant to do work with larger telescopes around the world. And that's something that we've accomplished. We've got that helping us. Astro Lynch was here before. That's Kyle. And Kyle wrote a proposal to Las Cumbres observatories, which included us, and they ended up naming us in the grant. So we can now, we're actually going to search for exoplanets around Barnard's star and around Mu Cephei, which is a red star in the constellation of Cepheus. And we're going to see if there was a survivor of this red giant phase in that solar system. Not sure it's ever been done. But Barnard's star, on the other hand, there is promising information that indicates maybe there might be a planet around Barnard's star, which is the second closest star system to us, over Alpha Centauri.
I saw an article just recently about discovery of a possible exoplanet around a star 6 light years away, I think. Was that Barnard's star?
That would be Barnard's star, yeah. So we're gonna do a confirmation study to see it, and we have access to some really nice telescopes, so that are designed for looking for exoplanets. So it's gonna be kind of cool.
I figured if it was 6 light years away, it's probably Barnard's star.
Yeah, Barnard's star is probably like 6.7 or something light years away. We took a picture of it the other night, guys, and where the database we're using thinks it is not where it is now. The reason is because this star is a fast-moving star, and in just 3 months, it won't be where you thought it was. It's going to move a little bit. It has a high motion through space. That motion through space is called proper motion. And so that's what we see. It's really cool. Let me first, now, while we're thinking about the other stuff, let me go see. Yeah, the Triangulum Galaxy is down here, and that's kind of below the pole. I can view just below the pole, so this is still too low for us right now. So I think that's going to make this galaxy, this half of the galaxy, our last image for the night. But look at this. Look at the detail up here. Isn't this amazing? Look at this nebula right here. You can see if I just put a little box around this. Check out that nebula right there inside the box. Okay. Look at this star cloud right here. Okay. Look at how detailed this is all in here. This is really, really incredible. Look at this line of stars right here. Okay. This is probably a line of star clusters. If it's actually in the Andromeda Galaxy, it might also be within our own, but it looks like it may be in the Andromeda Galaxy. Alright, there's another nebula right here in the galaxy, in the center of that tall piece. That's really something. So, we get a lot of very interesting little objects. Oh, there's another one right here. Yeah, that's crazy. It's beautiful. Let's zoom in. Yeah, these look like these might actually be in the Andromeda Galaxy as like clusters. Like a cluster of stars. Very interesting. Then we come up here. That's beautiful. Alright, we got 26. We got one more to go to get a 27. And if we end at 27 like we did with the other, we might get one more object in. That's me, just one more. Yeah, this is cool. Alright, so we'll save that, save it exactly as seen. Nice, so that's the Andromeda Galaxy, and those two halves we put together for our Patreon subscribers, or you can just take down this image here and use the other one, put the other half together. See how big? It's big. This is interesting. This is that other Measure 110 galaxy. You notice it has some dark... oh, I see our telescope needs to be focused again. It has a dark lane in here. This is actually an interesting galaxy because it has dust in it, and many of these elliptical galaxies don't usually have dust in them. So that's kind of interesting and different. Alright, so that's neat. So let's back out of this, kind of fill the frame with it. So Raul, there's your galaxy. I know you wanted to see the galaxies. You like the sombrero. This is the Andromeda galaxy.
If you like satellite galaxies, Astrophoto of the Day, APOD, has up a great picture for the day of the Large Magellanic Cloud. Excellent photo.
Okay.
I was not aware. It has one spiral arm.
Really?
Yeah.
I didn't even know that.
And they show it in the image.
Wow.
Really nice. Lots of hydrogen nebulosity going on in it. The Tarantula Nebula, of course.
Yeah.
And just tons of red nebulosity in the galaxy.
Very cool. All right.
With a right nucleus and one spiral arm. Looks to me almost like they used to have two.
Mm-hmm.
And it's probably quite possible that...
we might have ripped it off.
Right. The Milky Way took it.
Yeah. Many times these galaxies will collide, and the Whirlpool galaxy is an example of that. It's a pair of colliding galaxies. Okay, let's go up here. And let's see. Well, we did the wizard. You know what I'll do? I think that maybe we can do it now. Is it the Gamma Cygni Nebula? Oh, that's the bubble. We can do the bubble as our absolute last object. I think this here. What's this one? Oh yeah, NGC 7822. Okay, that wins. Right, we're gonna check out 7822. Okay, watch the telescope lean way over the back and go to this little nebula that's out there. I think it's right there. I'll do a quick, yeah, I think that's it. So I'm going to go a little north. And I'm going to go a little west. Bring it in. I think that's it. It's a pretty big object. It filled the frame. Yeah, that's it. Okay. Okay. Just move over a little more. Thanks, Daryl, for putting up.
Yeah.
Izabela says, Mark's in telepathic mode. I was just going to say, NGC 7822. Well, your wish is my command. Alright, so that's going to level out, go stable, and then I'm going to pull this over just a tad more to center this part up. Alright, there we go. Because there's a lot more going on. that we want to capture. So, all right. So this will be set up as a 20-second shot. And off we go. And we'll go out of low light mode, jump into deep sky mode, and wait for the magic to occur. And we'll see the last shot we took, which will clear. Gosh, that's beautiful. Lots of detail in there, guys. Just think that's 2.4 million light years away. You're seeing it 2.4 million years ago. All right, and now here is NGC 7822. And I gotta bring us up just a little higher. When the telescope is sticking out like that, sometimes the wind bobbles it, and it just takes one quick thing to happen. And then that happens, which is good. Yeah, okay. That'll work, because we're going to show the center. Alright.
Mark, Feng Wei said, where'd he go? He read somewhere that the prevailing thinking now is that M31 and Milky Way merger has already begun. What's your opinion of that?
Well, it's 2.4 million light years away, and our galaxy doesn't show any, I guess you'd call it, symptoms of such an incursion yet. If there's a study showing that our disk is starting to migrate toward the galaxy, that would be important. But right now, I haven't seen that. You could be right. He could be right.
Oh, that story's been going around lately.
All right.
I mean, if the Milky Way is really 100,000 light years across, and Andromeda is 2.4 million light years away, you're saying Andromeda is 24 Milky Way diameters away from us.
Yeah. So I don't expect, I mean, in the absence of anything else, the Andromeda, concentrated mass can affect us, and does. But is it warping our disk of our galaxy yet in any appreciable way? Hard to know. I'd have to look at the studies and see what they indicate. I don't think that they do, but I don't think they're warping it. But you know what? It could be. Let me just color correct this, by the way. There we go. I know I got it at the bottom here, but for tonight we'll do this, and we'll come back another night to 68, NGC 7822 as well, and we'll do the bottom half and then put it together. All right, there's 7822. This is an open cluster, guys. It was formed here. This is a stellar nursery. Lots of dust in here. This is all dust. It's not a void in the stars. And as we move further, you'll see that. I might be able to show that really quickly by over-processing here. Okay, this over-processing shows all the dust in here. All right, and the Starlink satellites that occasionally go through. So you see the dust clearly, and that is in front of the nebula behind it. And that's what we're seeing there. So let's bring this down and let's pull this up a little bit and bring back a little more controlled increase in processing capability here. And let's color correct one more time. With every exposure, sometimes you do color corrections. Alright, and you can see there's a lot of red showing up. That's the beautiful diffuse nebula that's here. And this is all that dark dust. I mean, this is all stuff that's light years across, light years thick, many light years, thousands of light years sometimes, long and thick. And so you say, how could that possibly happen? Where has it all been? Well, where did it all come from? It came from billions upon billions of young hot stars that only live a few million years, and they all went supernova and shed their contents to the interstellar medium, mixing and falling into gravitational wells, gravitational pulls of the galactic core, orbiting the galaxy, and making up fertile locations where new stars can form, because there's a lot of hydrogen out there, there's a lot of dust to make planets. So our Earth is not unique in the galaxy, and there's probably plenty of other carbon-based life out there. And guess what? Many astronomers feel that's true. Actually, if not most, now feel that carbon-based life is the way it is in the universe, because carbon is the most flexible atom. It can bond and break bonds, more importantly, with more things than any other element in the entire periodic table. And don't think about silicon. Silicon is actually too robust. It makes bonds that don't like to be broken. A piece of sand is silicon dioxide, silicon with 2 oxygen atoms. When you walk on the beach, you're walking on mostly gas. But consider that it's very, very hard to break apart those bonds. And so silicon is not as good for life's fundamental requirements of making and breaking bonds thousands of times a minute, which is what's going on in each of your bodies right now. But carbon bonds can be made and broken all the time. Complex sugars all need carbon. Like C6H12O6, okay, that sugar, it needs carbon. Carbon is the crux of that. Michael Hedrick says, so star nurseries are in the midst of star graveyards. That's kind of an interesting and romantic way to put it. But when you see a nebula, the nebula is the source of new potential life in the universe, right? New stars. And all stars are born in the dark. So out of a dark nebula, you might have this self-collapsing cloud, gravitationally contracting cloud. And that cloud is maybe generating heat in the center of it, and hydrogen, the most plentiful element in the universe, is being compressed in there, and thus, if it gets to a certain temperature, then fusion begins. And now it's by the very requirements of fusion, it's a large ball of hydrogen, effectively, and other elements that are in this cloud. For instance, look how nice this is coming out, by the way.
You know what element has the highest melting point?
I think it's one of the radioactive elements. I'm not sure.
Carbon.
Oh, I guess that's true, huh? I didn't know the melting point of carbon.
There's a new periodic video out today. Martin Polyakov and those guys over at University of Nottingham, I think. They did a video on rhenium, and they listed melting points. And rhenium has a very high melting point, but they showed it up to the top of the list, and carbon was highest at 3,500 degrees Celsius.
Interesting. I didn't know the melting point of carbon offhand. I thought it was a radioactive element, but I guess carbon would top it, because carbon is actually a burned product. That's pretty cool. You got people racing down your road there?
No, that's probably about a mile away from me, actually.
Oh, that sounds like a motorcycle or something.
It is. Sorry.
That's all right.
Getting fresh air while I still can.
Sure.
Back door is open.
JSEO says pretty shade of red. Yeah, that's the predominant transition made by electron of the hydrogen atom that rejoins the hydrogen atom after being ionized by the hot ultraviolet light of these stars. You'll notice down here we have these stalks, which are starting to show up now. Okay.
I was going to say, I remember that one.
Yeah, you see the stalk
Yeah,
here, a little one
The
there,
little one next to it.
and then more here. The stalks are the result of concentrated densities of material here that are hard for the stars to whittle away with their stellar energy. So they actually protect what's behind them on the lee side. So these stars' ultraviolet output can move dust that's not protected and gas that's not protected away and leave behind this. So that means that this area up here is the densest part of this in all likelihood. And so what's going on in there might be a collapse to form more stars and possibly planets. There's no reason that we may not expect that there could be some planets around the stars that formed inside here. And then, because the nebula is a transient, it's temporary. It'll go away eventually. When the stars that illuminate it, that cause it to glow, move away from each other or, evolve, they will become cooler and the nebula will no longer glow. Who knows how many nebula that we may see in the universe are close to not glowing anymore, because the stars that illuminate them are about to either go supernova or move out of that area beyond the ability to ionize that hydrogen. So that's how the stalks form. You also notice stalks like this in the pillars of creation with the Eagle Nebula, like we look at from time to time.
Exactly. We looked at last stream, if I remember correctly.
We did actually, yeah.
It's the very same process going on.
It is. It's erosion by the hot young stars, and this dense top areas are strong enough to withstand that erosion by this radiation and the stellar winds. Very powerful stellar winds. You got not just one star stellar winds, you got like 30 or more stars stellar winds, and they're all hot and young. So you're going to find that to be the case. Now, if these stars are in the right spectral range, then they won't whittle away too much material, and you'll eventually be able to see formation of planets and stuff in here. This is a beautiful little outcrop here. Let's try this. Just push it a little bit so you can see what's really in there. And I'll also take off the sharpening to kind of soften things up a bit for the moment.
Past your bedtime, Mark.
I know, I'm past midnight right now. This will be the last object. Yeah, this is beautiful. It's just how can you put away the universe? It's so hard for me to put away the universe. It's so beautiful. I can almost hear the rumble of the stars. Now people say you don't hear sound in space, but guess what? In a dense nebula, you will hear sound, because that's the medium through which the sound can actually travel. In this dense, dusty nebula, you might actually hear sound. Go ahead. I'm sorry, Daryl.
Can you show the stellarium view for a second?
Yeah.
I just don't remember where exactly we are.
I think Cepheus. Maybe not Cepheus. Are we in Cepheus right now? I think so.
Well, right between the Cepheus on the upper left.
Yeah, so I guess
We're right between Cepheus and Cassiopeia.
Yeah.
All right. Just about where I thought,
Yeah.
roughly.
Yeah, we're still in Cepheus, I think, because this is the border. The red is the border, so we're in Cepheus.
Barely.
Yeah, barely indeed. Yeah. Okay. Let's come back here. Very cool. All right, this is 37 images. This is great. This will actually work out to be a beautiful image, which will work up for you. I mean, this little piece looks like a stalk that's in the process of being whittled away here.
Yeah, I saw it earlier. A little blob of its own.
Yeah, I like that. Well, you'll notice it's pointing at the star cluster. You'll notice this is pointing at the star cluster. This is pointing at the star cluster. Blobs do that. Here's a dark, shadowy, dark dust line pointing at the star cluster. So this shows that erosion is occurring and the stars are pushing out in these directions in 3 dimensions toward us, into the page, up and down, and every angle in between. Very cool. Let's color correct and see if it changes anything. Yes, it does. Okay. Oh, very nice. I wonder if this that we're seeing here. No. Yeah, the observatory would be up here because we're looking upside down right now. The wall. Well, very cool. All right, so we're going to save this at 40 exposures. Okay, and save it exactly as seen. And this is what's going to be up on the server, right there. Again, you can get it by going to skytourlive.org. Check it out. And like I said, guys, we'd love to have you join our Patreon for as little as $3 a month. You can enjoy what we do and get some cool perks. At the upper levels, you actually get access to all the photos that are highly processed that we do. I'm about to upload a whole nother batch actually to the server. We got maybe 30 more on top of the 20 or so that are up there, 25 or so that are up there. But you guys, you have a good night. I can't resist to just save one more time. You know what, Daryl? I have an addiction, okay? I have a substance abuse problem, and the substance is the universe. You know?
Okay.
Yeah, I'm addicted to the universe. Bonnie Stanley says, how to join. Hi, Bonnie. I've known Bonnie for many years. If you go to skytourlive.org, you can see our Patreon. Our Patreon menu pick is up there, either at the upper right or so. I think it's at the upper right. And you can join the Patreon up there. And if you'd rather just donate, like Bonnie has been supporting us, I don't expect you to do that, Bonnie. That's very good of you, what you did for us. Incredible. But if people do want to donate, they can just go to skytourlive.org and click the donate button and donate to us. We just absolutely need this to keep going. Thanks, Kyle. I see you did the M33 exposures for your setup. That's excellent. I may look at it. All right, guys. I'll save at the even 45 mark because I'm still doing it. All right. Well, you guys have a good night, and we will catch up with you on the next clear night. Now, don't forget, subscribe, like, give us thumbs up, help us trend on YouTube, get us up there. Our goal is to reach 10,000 subscribers here very soon if we can. And by the way, hello Tiffany, I didn't say hi to you. I'm so sorry. I just noticed you've been in here and I haven't said hi to you. So good night, everybody. Goblin, good to see you as well. And I will talk to you the next night that we stream. All right, folks. You have a good night.
Good night, everybody.
And away we go. Good night, folks.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every